All right, ready? Add some energy.
Today we'll be testing out a new shotgun slug from no other than the celebrity machinist Tim Hamilton of Ballistic Machinist channel. Now this is a solid copper slug designed to open up when it impacts flesh and also fragment.
What do you call this?
I don't know what he's going to call it.
We're gonna name it. We're gonna name it Bodie McBoatface.
Bodie McBoatface.
All right, ready? Add some energy.
This first shot was fired at 1200 feet per second, what we would call a low velocity test because this can be loaded up and shot at much higher velocities. The slug managed to go through all the gel, and then it eventually was stopped by the Kevlar vest at the end of the table. Now if you look closely, you can see a couple of the copper petals that had sheared off and are now flying independently. Now the slug was recovered, and one of the petals was also recovered. Since only two of the petals actually sheared off, I consulted Tim Hamilton, asking him what kind of simple modifications I could do to the remaining slugs that will increase the expansion of them. Now he gave me several options to try. We decided to go with the second one, simply chamfering the intake of the hollow point, giving it a larger opening. As you can see, we also eliminated the steel actuator ball.
Okay, anytime.
Once again, the slug is traveling at 1200 feet per second, but we can definitely see a big problem there as the slug was just flying sideways through the air. Here's the recovered slug. Of course, no petals were open, no expansion occurred because the slug was flying sideways. Now, of course, a slug flying sideways or keyholing through a target like that is going to create massive damage to the gel, which it did.
All right, here we go.
Now the reason we are doing low velocity tests is because the loads that we're using have very low smoke and very low heat distortion, so we can get the best imagery with our cameras. Here we can see that part of the wadding, mostly the shot cup, is still attached to the slug itself. The slug is flying a little more stable in this shot, however it did hit the gel at a slight nose-up orientation. Looking at the damage on the table, we can see that the slug partially exited gel block number 5 and partially entered and sprung back out of gel block number 6. Looking at the recovered slug, we once again have no expansion and none of the petals were sheared off.
Okay, I might get bounced back on this one. Okay, hit it. Wow, listen to that thing. Went off that way though.
Wow, listen to that thing.
It's pretty apparent that the slug once again flew sideways in this shot, so let's see what happened in high speed. Greg was aiming at about a 10 o'clock position on the plate, and as you can see, it hit about the 7 o'clock position. Alright, let's continue with the 50-yard shot.
We'll go for center mass.
Yep, I'm ready.
Okay.
Miss.
Balls. It's on a wad. I don't know where that round went.
Yeah, that was... Those things have some problem. They don't like that. Our setup.
Although it's difficult to see in this shot, the slug again tumbled through the air, and then rather than dropping, it actually rose about 4 feet and then ended up hitting the brush behind there. Another idea that Tim wanted us to try was to actually anneal the copper slug, make it a little softer, and see if that will help with the expansion. We also loaded the shell a little hotter, and we'll shoot this at a velocity of about 1,300 feet per second. And we will shoot this into our stack of soaking wet magazines.
Okay, anytime.
They had some wallop to it.
Okay, anytime.
The slug went very deeply into this target, probably about 7 inches into this soaking wet mess of wet magazines. The slug was recovered along with 2 of the petals that sheared off, but once again we didn't have complete shearing of all 8 petals. Now it should be noted that Tim has already done a few tests of his own, shooting them through a fully rifled shotgun at a much higher velocity, and he has had nothing but success on his end. Okay, let's look at the high-speed footage. This time with the slightly higher velocity, we had better stability flying through the air. The slug hit nose first, exactly where Greg was aiming. Even though we had a lot of just flat-out failures on our end with these low velocity tests, we did determine that increasing the velocity only helps in this case. In a few days, Tim will be posting his results of his tests using a higher velocity shell and shot through a fully rifled shotgun. I'm really excited to see his results, so make sure you subscribe to his channel. Thanks for watching.